All right, so let's talk about exercise 9.51, problem 5, making it as a sheet metal intersection. So it's going to look like this. Essentially what we have is two cylindrical bodies meeting when they're different sizes. They are on center, as you can see, so it's not overly difficult, but if you look closely, um, it's not on center horizontally speaking. You know, it's 102 overall, and it's 50 from here to here. So we have 52 from here to this end. So it is a little asymmetric, but you know, conveniently, it is aligned in this direction. So it could be worse. You know, the book dimensions are really small, and this is metric part, as you can tell by the large numbers. So what we're doing is we're going to use some fake numbers. You know, obviously there's not sheet metal, it's 2.6 millimeters, but for proportional sake, these will be the values we use for this one. 2.6 for the thickness and bend radius, and a seam size of 1 millimeter, and the default K factor of 0.44. So I'm going to move this off, and then, you know, here's what we're working with. For your sake, you have this lovely DWF that you can use as your dimensions, or you can, you know, just reference the volume on it to see if you're right, whatever you're wanting to use it for, but you do have a visual reference. And I'll go ahead and show how I went about modeling this myself, and then we'll get into it. So, you know, basically we have to have 3 parts because the 2 side pieces are not exactly the same size. So let me go ahead and open them up. I didn't do anything crazy. The parts themselves are very easy. All we're doing is a base sketch, a second sketch offset from that, you know, basically just projecting that same sketch, doing a lofted flange with the die form option, making sure that it's flipped within the profile drawn, then a rip, and then our cut. And the cut is naturally going to be the profile of the other part. So pretty straightforward, and then unfold it. It's the same concept for the side piece on the other side. The only difference is, you know, our offset value is a little different because we have one of 50 and one of 52. And then the middle is essentially the opposite. So we have our round sketch down at the bottom. Then we do the opposite plane, and we have a sketch on the top projecting that bottom sketch, rip again, and then a cut of that side profile. So this one will actually be easier than the last one. And then when you're done, you can strain it together. And one thing I do want to point out. So I talked a little about it in my last video, but I didn't really elaborate on what cut normal is all about. So let's just talk about it. So if we were to open this guy and we look at the flat pattern of the holes, you can see that on the back side anyways, you can see that it's kind of warped. So like if they were to cut this out on a burn table, you know, it can't do that. It can't have this angled cut. It's hard to really tell depending on where you're looking, but it is angled. And that's why when I'm looking here at the back view, you can see it's got this double circle. And that's just not how it can actually be created using a burn table. So the purpose of cut normal is that when you hit, you know, the checkbox for it, when you go and unfold it, it looks like this. There's a little bit of, you know, like an edge it looks like, but it's basically none. It can cut straight through. This is a true how it would look shape. And that's the premise of cut normal, is to create it how the shop actually would have it come out of the table. The pitfall of that for what we're doing is it leaves this little gap. And, you know, for them, what they would probably do is make this run long, make this hole bigger, cram it in, and just kind of make it work because you have this big old gap. They would just cope with it, you know, they'd make it fit better. But for what we're doing, that's a little extra. So we're not going to use cut normal, you know, because obviously it's not going to be aesthetically pleasing. So just keep that in mind. That is the difference when I reference cut normal, is that, you know, you have true to size versus, well, true to fabrication versus a perfect environment where you can do whatever you want. So, and I already goofed because I opened up an Imperial template. This is on metric. And we'll convert it to sheet metal, set up the sheet metal defaults. So we want a material of steel mild. Our thickness is 2.6. Our K factor is already set, and our bin radius equals thickness. So we can just go ahead and hit save. And let's go ahead and save this part. We'll use this one to be the middle piece. And what I'll go ahead and do is save 2 copies. Well, 1 copy, actually. And we'll make this a side piece, the left side. Okay. Basically, that way I don't have to, redo the sheet metal defaults both times. And we'll start with the middle. And so go ahead and get a good look at this. Basically, we're doing a diameter of 50, an overall height of 76. So I'll just move this out of the way. Okay. So there's one. And we'll do our offset plane from the origin plane that matches. And that is 76. We'll draw a sketch, project the existing circle, do a lofted flange, die formed, and we need to flip the direction to make it hit the extents of the sketch. We'll go ahead and do our rip. Now I'm going to do it on the rightmost quadrant, so I'll project the existing circle. We'll do a horizontal to locate it, and then a coincident from the projected edge to the point. Go ahead and do the rip. We'll turn off that ugly little plane. Okay, so now we just need to do that little side cut. So I'm going to do a slice graphics. And that circle is 25. Now, judging here, it's 38 from the end to here. Naturally, that is the midpoint. So you could just, project some stuff and make it the middle. But what I like to do in a case like this is if it gives you that value, well, it may change. So I'm going to do the dimension because later on, say something changes, I could make it 24 and I wouldn't have to break any constraints. So we'll put that dimension, and then I'm going to align these 2 points. And we can do a cut both ways and through all. And just like that, we can make our flat pattern. We've completed that part. I feel like this one's a lot easier in the past assignment, to be honest, but you do have to make that extra part, which kind of sucks. All right, so we'll start with drawing that same profile again. And it was 25. And then we'll do an offset from plane. I'm going to do minus because we're going to do the left piece first. So it's 50 to the right piece. So this one's going to be minus 52 because 102 minus 50. Yeah, so basically I'm saying from here to here, that value. And we will do another sketch with projection. You probably thought, when you started looking at these, that these would be much harder than they actually are. But, if you go about it using lofted flanges, a lot of times it's a pretty basic process, really. And we'll just do the same thing, die form facing inward. So we've got the extent, and we can go ahead and rip it. Now for this one, oops, forgot my sketch. For this one, I'm going to draw the point down here on the bottom. A lot of times when you work at places, they want the seam to be kind of hidden. So when you're in assembly, if you can have that seam on the bottom so it's not just protruding out, that's usually ideal. So we'll do that. And then I'll do a coincident and align these 2 points, and we'll rip it. Okay. So now we just need to go and cut out the rest. So I'll rotate my view since it likes to always do that. I'll slice my graphics. And I'll draw on the origin point. The size for this is 50. Then we can actually just go ahead and cut through all both ways. Oops. Fun fact, sometimes if you do it too quick, it won't catch that little click there. Okay, so when I look at this on the top view, you can see it's got that contour now. What we can do is go ahead and save it. And save a copy of it. Name this one right side piece. And I'll open that right side one we just saved a copy of. Now, you know, in an ideal world, this would just work, but I'm pretty sure when we flip it, you know, from the origin here to going 50 over here, as the book shows, I'm pretty sure it's going to break a few things. We'll have to redo it, but it's still best to do it this way, just to save a little bit of work where you can. So I've flipped it to 50 this way. And I suspect, yep. So when you look, even though it maintained the loft, it does need to be now flipped because it's mirrored. So make sure you've got that extent as your direction. And other than that, I think we're good. You know, look at my sketch here to be sure, but yeah. Okay, good stuff. So we can actually go ahead and put it in an assembly. I'll grab those 3 pieces. We'll just place them arbitrarily in the view. And we'll constrain this guy to the assembly origin. But first I'm going to put on shaded with edges for the visual style so I can see a little better. And one thing I would like to do actually, so we have, you know, the bottom plane and the top plane. But what I always like to have for a piece where you're constraining to that center there is an actual plane for it. It makes it a lot easier. So we're just going to do a mid plane between these 2 planes. Okay, that should make this next step a little easier. All right, so we're going to go through and do YZ to YZ. They'll be flush. XZ to XZ, flush. XY to XY, flush. And then it doesn't move. Okay, so I'm going to position these guys in a place so don't get confused. We'll do the left side to the middle piece first. I did not mean to collapse the middle piece, so I meant to collapse the assembly origin. All right, so let's do YZ to YZ, XZ to that new midplane we made. And notice I'm just doing flush on all of these. It's if you draw them in the correct position, you usually can just do the same names and not have to look too much. So keep that in mind. And then XY to XY. And that one's done. So now we'll do the same thing with the right side. YZ to YZ. XZ to XZ. Oops, not XZ. I take that back. The midplane. And XY to XY. Okay, lovely. I turn on my degrees of freedom. Nothing moves. And we've got an assembly. Now, to check yourself, one, you could save it. You know, I'm not going to bother with the name. You get the idea. I'm actually not saving this for actually keeping. I've already got it modeled. So, but to check it, you can check your volume. And then you can do a half section view. And what we're looking for when we cut it in half is that you have these 2 corners that butt together perfectly. Because this is how they would weld it. They would essentially fill this corner, welding all the way around the inside. And, you know, they'd probably do it on the outside. But the general idea is, say you had something made with sheet metal, you can allow flow of whatever through and through seamlessly. So no protrusions. It's just a perfect meeting point. And it's surprising how difficult that can be to pull off. So, here you have learned in a relatively quick amount of time. So if anybody's having any questions about how to go about this one, just let me know.